Hey, welcome to this video where we'll be exploring the proof of the third logarithmic law. We want to prove how we come across the third logarithmic law. We've done that for the first and second this so far, and I hope you've learned to appreciate them because they're really interesting and they really help us understand where they come from. And you tend to notice that the first and second logarithmic law have very similar characteristics. But the proof for in this case, the proofs of the first and second have similar characteristics. But for the third logarithmic law, we will see a little difference in the technique. It's not, but they are more or less the same. And let's see exactly what I mean. So let's say I had a value y, right, which can be expressed as a to the power b. So y is a to the power b. And I want to see if I want to try and convert this into its logarithmic, I want to express it in a logarithmic way. That would be log, right, to my base of a, which gives me y, is b. And I'm assuming you already know how we do this, but just to recall, or just to jog our memory a little bit, the power that I raise a to give me y is b, right? And so I want to see what happens. Now I know y is equals to a to the power b, but what happens when I raise y to the power c? What happens when I raise y to the power c? Well, remember this. Y is the same as a to the power b, right? So y raised to the power c is a to the raised to the power b raised to the power c, right? You see what I mean? So now that we know this, what do we know about our indices when we have an index raised against another index? Well, we just multiply them. So that means y raised to the power c would be equals to a raised to the power b times c, which I'll just call bc, right? And we get it this far. And I don't like to have this bc around here just for my own sake, but even for yours, I think it makes it a lot clearer. So it'll make it a lot clearer if we then concluded that bc is z. Let's just say bc is z. So we can express it, and it looks a lot neater that way. I personally appreciate it that way. So y, right, raised to the power c is equals to a. Instead of putting bc now, we can just put z. We can just replace it with z. So y raised to the c would be a raised to the z. And I'm going to see if I can express this as a logarithm to my base a. And I most definitely can do that. And let's see how. Well, the log to my base a, which gives me this whole value here, which gives me y raised to the power c, right? The logarithm to my base a, which gives me y raised to the power c, is z. And this makes sense because what we're saying here is the power that I raised a to give me y raised to the power c is z. And we notice here, z is what we've raised a to give us y to the power c. But remember this, z is the same as b times c. Z is the same as b times c. So log to my base a of y of c is equals to, not z, but in this case we just want to replace it back again with this bc, right? We just want to rewrite the z again as bc. But remember this, b is the same as this value. B is log to the base a of y. That's what b is. So instead of b, we just need to plug in this little value over here. And so we can conclude that log to my base a of y raised to the power c. Oh, I just realized this. Let me make that a c. That's c. I hope you see it. Make this c over here green too. So log to my base a of y raised to the power c, is log. Instead of b, we put log to the base a of y, right? Multiplied times our little green c, which again we can rewrite. We can rewrite this. We don't have to show this multiplication sign. And I'm just going to put this all in green now. Log to the base a of y raised to the c is, instead of writing this, we can just write this as c log base a of y. And this right here is our little beautiful formula that we learned in the previous video. All we did was just drop the c down here, right? We just dropped the c, and that's what this turns out into. And I hope this proof made sense. I was hoping this z bit doesn't jumble you up. It really made it clearer for me, and I hope it did so for you. And hope you like it. See you next time.